number 8. Prove that sec theta into 1 minus sin theta into sec theta plus tan theta is equal to 1. We start from the LHS. So we write LHS sec theta 1 minus sin theta into sec theta plus tan theta. Now convert sec theta and tan theta into sine and cosine. So the expression becomes 1 upon cos theta into 1 minus sin theta into 1 upon cos theta plus sin theta upon cos theta. Now combine terms. Multiply numerator 1 minus sin theta into 1 plus sin theta becomes 1 minus sin square theta using difference of square formula, and denominator becomes cos square theta. Again 1 minus sin square theta becomes cos square theta using trigonometric identities. So we have cos square theta upon cos square theta. Cos square theta cancel. It gives 1. Hence proved. Moving to question number 9. If 3 tan theta is equal to 2, find sin theta and cos theta. Given tan theta is equal to 2 upon 3. So we take opposite is equal to 2 and adjacent is equal to 3. Now find hypotenuse using Pythagoras formula. Hypotenuse is equal to under root opposite square plus adjacent whole square. Substitute the value of opposite and adjacent so that it's equal to the under root 2 whole square plus 3 whole square equal sign under root 2 whole square becomes 4, 3 whole square becomes 9. Add these two numbers so that it's equal to the under root 13. Now find sin theta. Sin theta is equal to opposite by hypotenuse, which is 2 upon root 13. Cos theta is equal to adjacent by hypotenuse, which is 3 by root 13. Now let's solve question number 10. Prove that sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. LHS sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta equal to the factor the numerator so that sin theta into 1 minus 2 sin square theta. Factor the denominator so that it's equal to the cos theta into 2 cos square theta minus 1. Write the LHS as sin theta upon cos theta into 1 minus 2 sin square theta upon 2 cos square theta minus 1. Now sin theta upon cos theta becomes tan theta into 1 minus 2 sin square theta upon 2 cos square theta minus 1 equal to the, take it, tan theta outside, tan theta into 1 minus 2 sin square theta upon 2 cos square theta. Here use trigonometric identities. Cos square theta is equal to 1 minus sin square theta minus 1 equal sign tan theta into 1 minus 2 sin square theta upon 2 1s are 2 minus 2 into sin square theta becomes 2 sin square theta minus 1 equal to the tan theta into 1 minus 2 sin square theta upon 2 minus 1 becomes 1 minus 2 sin square theta. 1 minus 2 sin square theta upon 1 minus 2 sin square theta cancel. It gives 1, so that it's equal to the tan theta into 1. Tan theta into 1 becomes tan theta. It's equal to the right hand side. Hence proved.